Dear friends, in this video, we will look at another important machine learning algorithm called the support vector machines that is used in predictive analytics. And how this works, let's see in few videos. I call this as a journey in support vector machines SVM part 1, which is the first video. What is support vector machine SVM? Originally in the year 1963, it was discovered by Vladimir N. Vapnik, and the support vector mission has the goal of achieving the largest separation between two classes similar to the discriminant analysis. And we will see the similarities later, but right now let's focus. The objective of support vector mission is to separate the two classes in terms of the largest possible distance. And support vector missions are based on the concept of hyperplanes that define the decision boundaries. A hyperplane is one that separates the objects of one class from another. Of course, the idea is to find out the best hyperplane that can achieve the largest separation between the two classes. That is the main focus of support vector mission. Let's look at an example. There are two variables, predictor variables, X1, the aptitude test score, X2, the interview performance, and green color represents those who are hired, the red color represents those who are not hired. The idea or the goal is to draw the hyperplane that can correctly separate or sharply separate the two data points, classes data points, that is, those who are hired from those who should not be hired. So, what kind of separation is possible? What is the best hyperplane that I should draw that will separate those who are hired from those who are not to be hired? That is the goal of support vector mission. Linearly separable data points. The classifiers could be non-linear separable, but we will first look at the linearly separable data points. These are the two sets of data points, one cluster here, one here, and this is one hyperplane. It's okay. This is separating reasonably well, but this one data point is close to the divider. This is another hyperplane. This does better than the previous one. And yet another hyperplane, green color, which is separating these two classes. So which one is the best? Naturally, the one that achieves the largest separation between the two data classes, the data points classes. This is class 1, this is class 2. Red is not good, and this is blue. This is nice. The green appears to be the best. And that's how it is. So we will have to select the best hyperplane. We use a mathematical technique called quadratic programming. We will just see a little later. The data points that can be separated by a line, in general a hyperplane, is known as a linearly separable data point. The hyperplane acts as a linear classifier, just like the linear discriminant analysis. Good versus bad separator. Look at this. This is a bad separator. This is a bad separator. This is a good separator. The hyperplane achieves this, and the data points are far, far away from the hyperplane. And this is a magnificent technique. We will look at the other aspects in the next video. This is just the preliminary one called part 1. I hope you have enjoyed looking at the basic concepts of support vector missions. We will see you soon. Thank you very much.